Hi, welcome back. We are going to talk about properties of logarithms. So last section we learned what logarithms were and how they were related to exponential functions. Today in this video I want to talk to you about the properties of logarithms. And this is important because we're going to start combining them. So remember what we said in the last section, that logarithms are exponents so it follows to reason that logarithms will follow the same rules as exponents. Keep that in mind as we go through this, because I'm just going to kind of list off the properties and then we'll apply them. So, and what I'm going to do is I'm going to give you a logarithmic property. And I will give you the corresponding exponential property. So the first one is, remember that if we multiply two exponential functions together, we add the exponents. The logarithmic equivalence of that is that the log base b of a product is equal to the sum of the logarithms. Okay. If we divide two exponential functions, we subtract the exponents. The logarithmic equivalent is that the logarithm of a difference is the same thing as the logarithm of a quotient is the same thing as the difference of the logarithms of the factors. And if we have got an exponent raised to some power, we multiply the exponents together. The logarithmic equivalent of that looks a little odd, but I think you can see the equivalence if you think about it a little bit. What happens is if we've got a log base b of x to the r power, that's the same thing as r times the log of the base, the internal base. Think about that last one for a little bit and you'll begin to see some of the utility of logarithms. Logarithms pull exponents down onto the main line. They take them up out of the air and bring them down where we can do something with them. Okay, write these down and keep them handy. We're going to apply them right now, actually. So let me see if I can arrange this so you can still see them. Okay, that'll work. So let's expand log base 5 of 3xy over z. What this means is apply these logarithms to write this as a sum or a difference of, apply these logarithmic rules to write this expression as a sum or a difference of logarithms. So the first thing we're going to do is we're going to apply the product rule so that we see that this is the log base 5 of 3xy minus log base 5 of z. Now we'll apply the product rule and write that this is the log base. So this first part splits as the log base 5 of 3 plus the log base 5 of x plus the log base 5 of y minus the log base 5 of z. Notice my base never changes. There's only one way we can change the base of a logarithm. We'll talk about that later. When we're doing these expansions, the base never changes. The only thing I do is I apply these rules of logarithms to expand my original expression into individual logarithmic values added together or subtracted from one another. This log base 5 of 3, if this was something that we could simplify easily, like the log base 2 of 8, which we know is 3, we would do that. Otherwise, we'll just leave it this way. All right, now as we get faster, we'll do this all at once. Let's do another one. Let's expand the log base 2 of x to the 4th over square root y times z. Okay, now we know everything in the denominator is going to be subtracted and everything in the numerator is going to be added. So this is the same thing as the log base 2 of x to the 4th minus the log base 2 of the square root of y. Let's take this step by step. So in the denominator, we have a product. So that would be plus the log base 2 of z. But this product is entirely in the denominator. So we are subtracting this entire sum. So we have to distribute the negative sign. And you can do that all in one step. I just wanted to explain why we were doing it this way. And now we're not quite done. We have some exponents inside our logarithm. So we're going to apply this last rule. And this is going to be 4 times the log base 2 of x minus. Now in order to do this one, you need to remember that the square root of anything is equal to that anything to the 1/2 power. So this is minus 1/2 log base 2 of y minus the log base 2 of z. And that is the expanded form. Hope this makes sense. Let's do another example wherein we go the other way. So sometimes instead of expanding, we are asked to write as a single logarithm. For example, we want to take the expression 2 times the log base 10 of a plus 3 times the log base 10 of b minus 1/3 the log base 10 of c. And we want to collapse this back into a single logarithmic expression. So the first thing we want to do is apply our exponential rule. So this is the log base 10. Numbers in front of logarithms become exponents inside. So that's a squared. That's this third rule applied kind of backwards. Plus the log base 10 of b to the 3rd power minus, this is going to be the log base 10 of c to the 1/3 power. But let's remember that c to the 1/3 is the same thing as the cube root of c. So I'm going to write this as the log base 10 of the cube root of c. Okay, my bases all match, so I can combine these logarithms together using my rules. I've got two things added. Those two things are going to be multiplied together. And I've got a logarithm subtracted, so we know we're going to divide by its argument. Okay? Now here's why we would want to do that. Suppose we are asked to solve. So we want to solve for x. This equation that says that the log base 2 of x plus 2 plus the log base 2 of x equals 3. Our x's are inside our logarithm. So what we really want to do is write this logarithm in exponential form. But before we can do that, we need to get this left-hand side to a single logarithmic expression. So let's just combine these two together. They're added, so we know it's a product. Now let's write this in exponential form. 2 to the third power equals x times x plus 2. Simplify and distribute, and we get x squared plus 2x equals 8. Pull the 8 to the other side so that my polynomial equals 0. And solve however you prefer to solve quadratics. I happen to know this will factor as x plus 2 times x, or x plus 4 times x minus 2. So x is -4 or x is 2. But now remember, we talked about logarithms before. What was the domain of a logarithmic function? If you've got the log base b of x equals y, x must always be greater than or equal to 0. So just like in other applications we've seen, we have some extraneous solutions. The negative number is not in the domain, and so therefore x equals 2 is the solution to this equation. Wait a minute. Yes. Okay. That's it for section 6.4. I hope that this has been helpful. We will continue later talking about some special logarithms, which are common and natural logarithms, and those just indicate specific bases. All right. Everybody have a great day.